Okay, you see you have the same pattern. When you have the square root function, then you set whatever inside the square root greater and equal to 0. So you have 25 minus 4x squared minus y squared greater and equal to 0. Okay, and then you will have 25 greater and equal to, mean negative bring to the other side, so become 4x squared plus y squared. So we would like the variable at the left side. So if you turn it 25 greater and equal to 4x squared plus y squared, or another way mean 4x squared plus y squared less than or equal to 25. Let me stop here because a nice form. This is a elliptic equations. So this will be the domain 4x squared plus y squared less than or equal to 25, where x real number, y is a member of real number. Okay, and then range, same thing. Range here, when you have the positive square root, your range is actually z greater than equal to 0, where z is a member of real number, because the same reason here, same reason with question 1b. Your mean the function inside the square root function, minimum is 0, so square root 0 you get 0. When the functions that positive, square root positive number, you get positive. That's why you have 0, and the positive number means that z is greater than equal to 0. So this is question 1c. Okay, and then a slightly different, maybe question 1d. Z equal to fxy equal to ln x squared minus y. Question 1d. Okay, for the ln functions, okay, you look back a function of one variable. Let's say you have y equal to ln x. Okay, the graph of ln here, mean this is 1. When x is 1, ln 1 is 0. So this is x, this is y. So for y equal to ln x, you notice x you cannot have ln 0. Ln 0 is infinity, undefined. That's why for y equal to ln x, x must be positive. X must be positive. Ln 0, you press it, undefined. That's why the domain for y equal to ln x is actually x greater 0, not included 0. So x is greater than 0, where x is a member of real number. Range is a y. You see y, you have a negative number, 0, positive number. That's why y is actually belong to real number. So with the same reason for a ln function, you see if ln x, you have to set x greater than 0. Then for ln x squared minus y, you have to set x squared minus y positive. If not, if x squared minus y you get negative, is 0, or negative number is undefined. That's why you have to set for ln function, you have to set the argument there greater than 0. That's why you have x squared greater than y, or y less than x squared. So this will be the domain. It's actually y less than x squared, where x is a member of real number, y is a member of real number. Okay, and then the range. So range, okay, follow the same thing. Ln function, you see here the range is a real number. That's why here the range of z also real number. Basically, for function of two variable, you can try to make the analogy with the function of one variable, because function of one variable you can sketch the graph easily. Okay, the range for function of one variable is actually the y. You can see the y from the graph there. Okay, domain is actually the x value for function of one variable, because you can make the same comparison there. So this is question 1D for z equal to ln x squared minus y. Okay. So for quotient function, you have to set denominator cannot be equal to 0. If not, then you have any number divided by 0 become infinity. So that's why to avoid you get infinity, you have to set x minus 2y cannot be equal to 0, or x cannot be equal to 2y. So this is the domain. Okay, x cannot be equal to 2y, but where x is a member of real number, y is a member of real number. So this is question 1E. The domain is x cannot be equal to 2y. Okay, the range here. Okay, for example, you have y equal 1 over x. So x cannot be equal to 0. So the domain for function of y equal to 1 over x is actually x cannot be equal to 0, where x is a member of real number. Okay, and you look at the graph of y equal to 1 over x, is actually you'll get some sort like here. Mean the graph here, because x cannot be equal to 0, and then so when x is very big number, 1 divide big, you get very small number. When x 1 divide a small number, you get a very big number. That's why this is for positive side, and then when x negative side, y also get negative. That's why the graph is here. You see the range is actually y. Y cannot be equal to y is never touch 0. Okay, when you look at the graph of y equal to 1 over x, y never touch take the value of 0. So similarly, this one can have y, the range is z. So z should be cannot be equal to 0. Z is a member of real number. Follow the same pattern here. Okay, but the answer z is a, can you get z 0? Okay, because here, let's say x0, y0. This one, because it's 1 over x, 1 over x, x never 0. So y will never get 0. But here, if x is 0, y 0, so still satisfy x not equal to 2 times y. And then z you can get 0. That's why we have no restriction. So that's why this case, the domain, the range is actually z is a member of real number, not because this one is 1 over x. 1 over x. This one numerator is x times y, and x can real number. Let's say x is 0, y is 0. So yeah, numerator 0. 0 divide anything, you can get 0. That's why z here, no restriction like here, y cannot be equal to 0. So the range is actually z is a member of real number. Okay, this is question 1E. Okay. So z is fxy equal to y plus 1 over x. Okay, so tas hari ni. For quotient function like this, denominator you have to set what? Denominator is x. So can x equal to 0 or not? Okay, Tasharini, are you around? Tasharini. Okay, can you hear me? This is similar to question 1e when you have the quotient functions. Okay, denominator cannot take 0, otherwise it will become 1 divided 0 will be infinity. So that's why here you just need to set x cannot be equal to 0. So okay, so y plus 1. So y at numerator, y can negative, positive, or 0. So y is a member of, okay, so mean the domain will be x cannot be equal to 0, where x is a member of real number, y no restriction. That's why y is a member of real number. So this is question 1F. Only x cannot be 0, but y can take up no restriction, so y is a real number. And the range here, the range y is real number plus 1 still real number. So the range should be z is a real number. So this is question 1F. Okay, question 1G, z equal to cos x minus y. Okay, you just compare with function of one variable y equal to, let's say, cos x, y equal to cos x, and you see the graph for cos, this is 0 to 2 pi. Of course, the pattern is repeated, because this is a periodic graph. Okay, so like here. So you see if y equal to cos x, actually the x is a member of real number. I mean the domain is actually x take up all the real number. Okay, the range, because the graph of cos is from minimum value of y is negative, maximum is 1. That's why the range is actually y, you can have -1 up to 1, where y is a member of real number. Okay, so follow this pattern, then z equal to cos x minus y. X and y should be should take up all the real number, cause same pattern. Mean for cos x, is actually real number. So here x and y just real number. Because there's no restriction for cos function. The argument for cos function can actually, you see x here, x real number. So you got x minus y. X can be real, y can be real, no problem. And the range follow the function of one variable, but the range is actually z. So z is actually from -1 to +1. Where the z is a real number. So this is the answer for questions question 1G. Here even though I said square root function, you set whatever inside here, whatever inside square root functions greater and equal to 0. But this one no need, because for example you put -2 squared, you have positive. So whatever that you squared it is always positive. You put 0 squared, 0 lah. So that's why x squared plus y squared, x squared minimum is 0. Mean x squared always x squared always give value greater than equal to 0. y squared, okay, already, okay, guaranteed value is greater than or equal to 0. That's why in this case, even though I said, okay, square root function, to avoid you have the complex root, you will set whatever inside square root is greater and equal to 0. But because x squared is always positive, y squared is always positive, so there's no condition at all. Mean x can take negative number, because squared you get positive. X can take 0, of course x can take positive. That's why in this case, your domain, there is no restriction at all. Mean the x belong to real number, y belong to real number. So you can see, okay, to find domain and range, okay, for square root function, even though I said you said you have to set whatever inside square root functions greater than or equal to 0, but because this one, x squared is always greater than or equal to 0, y squared is always greater than or equal to 0. That's why this one, x and y are belong to real number. Okay, and then how about the range? Okay, this is 4 is positive. Your z, okay, you have 4. Okay, and then the square root functions here, you can have maybe 0, maybe greater than 0. So 4 minus 0, the result, you may still have 4. 4 minus something greater than 0, you may have the negative value, because as long as the number greater than 4, let's say 4 minus 5, you may get negative. Okay, is it, okay, 0? Is it possible you get 0? 4, 0 is 4. So mean at most is, okay, 4. Okay, at most is 4. Right. Or is it real number? You have to look at here. Okay, for the square root functions, you will get the value. This one, minimum is 0, maximum positive. So 4 minus, okay, for example, greater than 0. Let's say put 1, 2, 3, 4, 5. So 4 minus 1, you have, okay, let's say 4 minus 1 is, okay, you get 3. 4 minus 2, 2. 4 minus 3, you get 1. 4 minus 4, 0. 4 minus 5, negative. Okay, 6, negative. So the number actually you have 0, 1, 2, 3, 4 and negative. That's why, okay, the range is actually z, take up all real number. Because here I take integer number, you may have 1.1, 1.2, something like that. Okay, so this is question 1H. Okay, but this is what? Z less than or equal to 4. Yeah. You see the value when, okay, the z, when this part, the square root part, minimum is 0. Minimum is 0. So 4 minus 0, you have 4. So you see the maximum value is actually z is 4. Later on, the value going to negative. So this one, the correct one is x should be z less than or equal to 4, and z is a member of real number. Okay, because you see, okay, the value here, 4, okay, minus square root, okay, you can, minimum is 0. Okay, later on, okay, the value can be greater than 0. Let's say you put 1, 2, 3, 4, 5, 6. So 4 minus 0 is 4. Okay, and then you may have 1. Let's say 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3, 1. 4 minus 4 is 0. 4 minus 5, you get negative. So you see, okay, the value is actually maximum is 4 and reducing to the negative side. That's why z is less than or equal to 4. And z is a member of real number. So this is question K1H. Here, okay, domain is correct. X squared, because of the squared, so x and y, you can take up all real number. Because like this, your x, okay, and y can be positive, 0 or negative. Because when you square it, okay, so and when you square it, the result is actually when, let's say put like this. When you have positive, you square the result, okay, positive. Okay, this one is positive. You put a positive number, you square it is positive. You put 0, the result is 0. You put negative, the result is positive. Okay, so the result is actually your range. And then you have plus 2. Plus 2. So mean if, okay, so positive, okay, plus 2. Okay, let's say you see, you have positive value plus 2, or you got 0 value plus 2. So okay, the resultant value minimum is 2. So let's say this is 1. Yeah, okay, 1, so 1 plus 2 is 3. So 2 plus 2 is 4. So the value is, okay, from minimum 2 until positive infinity. That's why the range is actually z greater and equal to 2, where the z is a member of real number, and the domain cos x squared y squared, no restriction, x and y can take 0, positive or negative number. That's why x is a member of real number, y is a member of real number. So okay, so this is 1i, so soon understand it very well. Okay, so let's look at this one is okay, Soliha will be similar to H.
Yes.
So should be easy. You want to present?
That I use phone.
Ah,
So
phone cannot, is it?
not sure, but I explain.
Yeah,
Okay.
okay, you can explain, no
Okay.
problem.
Uh, for domain that has three variable. And this all is a positive value.
Mm,
So domain XYZ is the real number,
yeah, correct.
and
Mm,
okay, and the range greater than 0.
mm,
So there is real number too.
yeah, correct.
Okay.
Thank you. Okay, let's see 1J, 1J, 1J. Here 1J, your Z is actually x squared plus y squared plus z squared. So Soliha here, this one done. Okay, Ashikin, do you have problem? 1K.
Yes, yes.
Yeah, you want to present it or not?
I just want to explain.
Oh, you just want to explain? Yeah.
Uh,
So what?
um, for the denominator, yang saya tahu lah, it is always greater than 0, right?
Numerator or denominator?
Denominator.
Or denominator. Okay, but dia minus dia tolak.
Minus.
Even though x squared ini positive, y squared positive, z squared dia positive, tapi 9 tolak yang positif, tolak lagi yang positif, tolak yang positif. So ada ke you guaranteed dekat dalam ni sentiasa positif ke tak? Atau kosong?
Yang 9 tu bawa pergi sebelah. Lepas tu yang XYZ tu less than 9 lah, kan?
Okay. So untuk yang ni you kena setkan. Okay, kalau untuk pengiraan jawapan anda, you kena setkan 9 tolak x kuasa 2 tolak y kuasa 2 tolak z kuasa 2 greater and equal to 0.
Greater and equal to 0.
Lepas tu x squared, y squared, z squared pindah ke sebelah kanan. Lepas tu you manipulate dekat situ lah. Dia sama macam C, question 1C and question 1B. Okay, how about the range dia?
Range dia all the variables are
range
members with the real number.
why? 真的到 their real number? Cause x is real number. Okay, numerator x is real number, divide denominator, you can have 0 or positive number. So real number, let's say divide by 0, you have okay, cannot divide by 0. Okay, so that's why for k here, you cannot set 9 minus x squared minus y squared minus z squared. You cannot set it equal to 0. You can only set it greater than 0. Sebab dia tak boleh, you cuma boleh set dia greater than 0. Kalau tak, nanti you akan x divide by 0, dapat infinity. So, okay, kalau B dengan C, you set whatever inside greater than equal to 0. But because your square root function at the denominator, okay, denominator okay, cannot be equal to 0. That's why you only set 9 minus x squared minus y squared minus z squared greater than 0. Tak boleh ambil nilai kosong. Sebab kalau ambil kosong, dia akan dapat infinity. Okay, kalau macam tu, you square root a positive number, dapat positive. So real number divide positive number. Real number positive negative 0. So you real number divide a positive number, you still get real number. That's why range is real number, correct? But you have the in the test you can write the answer, but here because answer is there, that's why I want you to explain. So I hope you okay. So you can understand, right?
Yes, doctor.
Okay, thank you. Okay, let me explain one more time. K. Question K. Cannot Z W. So W here. So when you see whatever, you have the square root, if the square root at the denominator, in order to avoid you get divide by 0, you get infinity, then you can set the square root function positive. Square root function positive only. So from here you manipulate, okay, negative x squared, negative y squared, negative z squared, bring to right hand side. So you get 9 greater than x squared plus y squared plus z squared. Hence, okay, x squared plus y squared plus z squared less than 9. That's why your domain will be x squared plus y squared plus z squared less than 9, where x, y, z are member of real number. Okay, to determine the range is actually the output. Okay, mean the depend on the input, x here can be real number, mean you got positive, 0 or negative. Denominator cannot be 0, and this is positive square root, that's why it's only take positive number. So positive divide positive, you get positive. 0 divide positive, you got 0. Negative divide positive, you get negative. So mean the range take out positive, 0, negative, mean range is actually W is belong to real number. So this is question 1.